in this problem, we have to find the value of 1/2 plus 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the power of 4 plus ... plus 1 over 2 to the power of n. So first of all, notice that this is a geometric sequence with a common ratio of 1/2 and a starting term of 1/2 also. But in this video, I will not be using the sum of a geometric sequence formula. Instead, I'll be using two methods, the algebra method and a geometric method. So first, we can start with the algebraic method. So method 1 is algebra. We know that the common ratio is 1/2. And then a common method to solve this kind of problem will be to first manipulate it and then subtract the two equations so that we'll be left with only the parts that are different and the common part will be subtracted. To manipulate the equation, we can multiply it by 2. So if you let the first equation as this equals to Sn, then we have 2Sn equals to 2 over 2 plus 2 over 2 squared plus 2 over 2 cubed plus all the way to 2 over 2 to the power of n. And then we notice that this part, these cannot be simplified. So this will equal to 1 plus 1 over 2 squared plus 1 over 2 plus 1 over 2 squared plus 1 over 2 to the power of n minus 1. And then we can just call this as the second equation, this as the first equation. So we have equation 2 minus equation 1 will give us that Sn equals 2. So this entire part will get cancelled out. And then we will be left with 1 minus 1 over 2 to the power of n. Then we observe using extremization method. So we have, if we have n increasing, because we want to find the range of Sn. As n increases, well, 1 over 2 to the power of n will decrease. Or in other words, it approaches 0. Because 1/2 is 1 over 2 to the power of 1. 1 over 2 to the power of 2 equals to 1/4. 1 over 2 to the power of 3 is 1 over 8. And they just keep on decreasing. So we have S of n approaches 1. So if this is infinite, then we have it will be equal to 1. So S of n approaches 1. Then for method 2, we'll be using geometry. So once again, in the algebra method, we had 1 minus 1 over 2 to the power of n. So in geometry, 1 corresponds with a square of sine length 1. Then 1/2 will just mean half the area of a square. So we can just draw a square. With sine length 1. And then 1/2 will mean the area of the square is 1, so 1/2 is just half of the area. So it's a rectangle with size 1/2 and 1. Then the next one will be 1/4, which is 1/4 of the square. So it'll have side length of 1/2 and 1/2. And then the pattern continues with rectangles and then squares. And then the squares and triangles, rectangles area will just keep on decreasing. And then soon the size of the square will be approaching 0, but their sum will make up the area of the square. So the sum of all these rectangles and squares will eventually sum up to 1 if it's an infinite number, because the areas of the rectangles and squares will approach 0. And then their sum will approach 1. So that's how you solve this problem using algebra and geometry.